All right, example 2. We're going to locate vertical asymptotes and sketch the graph of this. Now again, I know you can type this in the calculator, and so that's why I'm giving you the picture right here. So how would we find the vertical asymptotes? Now, the first thing I want to point out is this is a reflection over the x-axis. The reason it's over the x is it is vertical, which you might be thinking. And you might be thinking, since it's vertical, shouldn't it be over the y? And I understand why you get that, because you think of y going up and down. But if it's a vertical reflection, that means what's up here goes down here. Now, which axis are you going over? You're going over the x-axis. Now, that's why that happens. But if you wanted to know the vertical asymptotes, this is when the denominator equals 0, just as I pointed out in the first video. When does a denominator equal 0? So if we're dealing with tangent, psi y cos x, tangent is y over x. So you're looking for cosine. When will the cosine of this equal 0? Or, said another way, when will negative cos, and the negative doesn't really matter because 0 is going to be 0. When is cosine of x over 4 equal to 0? That's what we have to establish. Now to find this, we're going to do the inverse because we want to switch these two values. We don't know what x is, but we do know what 0 is. So we're going to say cosine inverse of 0 equals x over 4. That's how we're going to solve this. Our one step will be to multiply by 4. And this will give us the value in radians, because my calculator is in radians mode. So I'll go back over to the calculator, and so I have 4 times the cosine of 0, and it says the answer is 4. Now this is in radians. All right, so 4 equals x, which doesn't do us much good on this, because you see that 4 is not listed anywhere. And I just realized I typed in something wrong here. I did not hit cosine inverse. Notice I typed in normal cosine. Let's try this again. Cosine inverse. Some of you were probably confused there. Cosine inverse of 0. Now we're getting a different value. We're getting 6.28, and you might recognize that. So this is incorrect here. We're getting 6.28, and it goes on and on and on, so I'll just do it like this. Now, if we wanted this in radians, what you do is you would just divide the value by pi. So I'm going to take this, and I'm going to divide it by pi. And you'll see the answer is 2. So this means the asymptotes occur at 2 pi. So if the first one's at 2 pi, let's check it. Yep, it's at 2 pi. The next asymptotes, or the other asymptotes, would not only be occurring at 2 pi, whoops, but then you would add the whole period. Now, how do we find the period again? We take the b. Well, here, our b is 1/4. So I'm going to put this over here. b is 1/4 because I have 1 divided by 4x. So to find the period, you take your pi and divide it by the p, which is 1/4. And just like the last problem, how do you get rid of a fraction divided by a fraction? Well, you take the numerator and you multiply it by the reciprocal of the denominator, which would just simply be 4 pi. So the asymptotes would be starting at 2 pi, and then every time you add 4 pi. And so the way they would put this is 4 pi z. That z just means any integer. You just multiply it by an integer, and that's how you get the other pi. So it happened at 4 pi, at 2 pi, at 6 pi, at 10 pi, or if we went this way, at 2 pi, -2, -6, every time you change by 4 pi. That's how you would find your values here, is by this. You just add or subtract the period. And I didn't do this on the first video. I really should have. So when I have down here the asymptotes, you could have concluded by saying the asymptotes, the vertical asymptotes, for that matter, would be at 1 pi, 1.5 pi, plus, remember our period here was 3 pi, 3 pi z. That's how you would actually do that from here. And that would be your vertical asymptotes on this one. So if you wanted to conclude example 1 a little bit better, that's how you would do so. Now let me try part 2 here. It says locate any vertical asymptotes and sketch the graph. Okay, so this time we're a little bit different. So again, this is tangent, which is y over x, so that's cosine. So we're looking for when cosine of this equals 0. So this is to find the asymptotes, is what I'm going to try to find here. I start with saying, when does cosine, and the negative, it does flip it, but it doesn't affect the 0. 0 is still 0. When if cosine of x plus pi over 2 equals 0. When does that occur? Well, the first step is to take the inverse. So cosine inverse of 0 will equal x plus pi over 2. And our last step is that we're going to subtract the pi over 2. Since it's adding, I do the opposite. So I'm going to come over here and subtract pi over 2. And that means my asymptotes will occur at cosine inverse of 0 minus pi over 2. And I'll keep the parentheses just so we don't get confused on if it goes in or out. That will equal our x, or our vertical asymptote. So let's go over to our calculators. Cosine inverse. I'll make sure I do it correctly this time. Cosine inverse minus pi divided by 2. I press enter, and I get the value 0. So that means I should have a vertical asymptote at 0. Let's check the graph. They didn't even put this one there. They should have. We should have one. Hold on, I'm getting out of line real quick. We should have one at 0 here. They didn't add it. But you can see in the picture it does have one there. Now, how do we find the other ones? Well, we'd find the period. And how do you find the period? You use your B. Now, this is C. Here's our B. And I'm going to change colors here. Our B is 1. And so the period would be pi divided by that B, which is 1. So it's simply put pi. Every pi, we should have an asymptote. So to write your vertical asymptotes, you would start at 0, and then you would add pi times that integer z. That just means any real integer. This is where they would occur. Let's see, locate any asymptotes and sketch. Well, you can just type that in the calculator to get that picture. Now here's one for you to try. See how you can work through this.